Hello and welcome back. Here we are once again at Botany 101, and my name is Angela Nishimoto. Remember last time when we had our lecture, we talked about the grasses, right? Well, today we're going to talk about some plants that are complementary to the grasses, okay? So, we're going to be doing the legumes, okay? All right. So today, our objectives include, okay, we're going to talk about what family the legumes are in, right? We're going to talk about how important they have been and may continue to be in human nutrition in that particular role. Furthermore, we're going to talk about one of the reasons why they are so important in human nutrition. We're going to talk about nitrogen fixation just a little bit, okay, in root nodules. And then we're going to talk about the bean family members. That sounds like a real family, doesn't it? Yeah, somebody named Bean, okay? So first of all, okay, so the legumes, right, the different kind of legumes are in the family called the Fabaceae. Okay, faba means bean in Latin. Right? And the family Fabaceae, remember that when we talked about plant families, they end in A-C-E-A-E. So Fabaceae, this is equivalent to what another group, or the same group, that people used to call the Leguminosae, all right? So there are a bunch of different families, maybe about 4 or 5 different plant families where they have alternate types of names, but usually people use the A-C-E ending. So the Fabaceae are it, all right? So the Fabaceae, okay, all members in the Fabaceae are dicots. Do you recall that we talked about the fact that dicots have 2 cotyledons? Remember way back when we talked about this? And we have reiterated this a few more times, right? So dicots have 2 cotyledons. Here's 1 and here's 2. And the 2 cotyledons are also known as seed leaves. When the seed germinates, when it actually starts sprouting, and first the root, the radicle goes into the soil, whereas the upper part kind of comes up. Okay, above ground usually. And here you see the 2 seed leaves, whereas these 2 leaves are older leaves, and these are 2 of the 2 first true leaves of that particular plant. So if we go under the elmo here, okay, we can take a look. Here's a peanut, all right, I've been snacking on peanuts. When you open it up like this, okay, for one thing, the 2 halves of a peanut are the cotyledons, yeah, the 2 seed leaves, right? And if you look at them, take a look at it, here, this little thing here, this little nub that you see sort of here, that is the embryo. Of course, it's not alive anymore because these are peanuts that have been roasted, but this here, it was the embryo, okay, of this particular seed. Because of course, peanut, the part that you eat, is actually the seed, and usually in a fruit, okay? And the fruit itself is known as a legume. Right? So generally dicots, 2 cotyledons. So that's what happens when you kind of dissect out a peanut, or if you dissect a bean. You know, like if you have some dried lima beans or pinto beans or something like that, you can actually get one of those seeds, because they are seeds, split them open, you can actually see a tiny little embryo in there, okay? Alrighty, furthermore, okay, there are 3 main types of flowers in this family, depending on what taxonomist you're listening to or who you're citing as an authority. All right, so there are 3 main types of flowers, okay? Remember we talked about before that when you do taxonomy, when you classify living things with flowering plants, you go by the flowers, but we have 3 different types of flowers when you look at them. For one time, you have what they call the mimosa type. Okay, and this here, a lot of you might recognize this, especially if you live in sort of wet areas, you know, Mililani or over in Kaneohe, place of Hilo. This is actually Mimosa pudica. People call it sleeping grass. And these are the leaves. Yeah, leaves are pinnately compound, right? So if you touch it, what happens? The leaves lose their turgor and they kind of fold open to close, right? So the mimosa type is this type where you have the inflorescences with the most conspicuous parts of them being the stamens. You can see the little anthers at the tips on some of these. So mimosa type of flowers, and we have another couple of examples, one of which is one of the main forest trees in Hawaii. This is Acacia koa, also known as koa, yeah? People know it as koa, and it does have the same kind of inflorescences, right? So this is Acacia koa. You can see that here you have the typical leaf, so-called leaf of the Acacia koa, right? It's actually a flattened, extended petiole. All right, but still here, you have a fruit of this plant also, which develops from the flowering head. And this here is actually a fruit, and that's a sort of characteristic fruit of the legumes. Okay, anyway, we're talking about the flowers right now. So this is a mimosa type flower. Thirdly, we also have a close-up here of a flowering head of what we call koa haole. So koa haole just means foreign koa. This was brought over, okay, to Hawaii as a forage. And you can see here that you have all these small, tiny little flowers making up this little puff ball. Okay, so this is another example of a mimosa type. This is why Hawaiian people call this plant the koa haole, because for one thing, it had similarity in terms of the inflorescence, okay, to the actual native koa. People here are very good observers of nature and other phenomena. Okay, we also have the faba type. Faba type of flowers. So this is like a characteristic type. It's kind of closed looking. All right, faba type. And here you have another, and this is butterfly pea. Okay, this is another different species, another different genus of this group. Okay, this is actually a very large family of flowering plants. Okay, and here's another example. This is called mucuna, and I believe that this photograph was taken over at the Lion Arboretum. There's this very large, woody vine that climbs into this, I believe it's a fig tree, some kind of a fig, Moraceae member, and it's like has these jade flowers, like the jade plant that people make those leis with, which are sort of like a bluish green color. Well, here's one that is red. Can you imagine a lei made of this? Except, of course, the inflorescences are way high up in the tree, like 40 or 50 feet up in the air. But isn't this kind of spectacular sort of ornamental plant? Isn't that beautiful? Okay, so some examples of the faba type of flowers that these plants have, okay, members of the Fabaceae. We also have another type, which is the Caesalpinia type. Okay, so 3 different types of flowers, all members of the Fabaceae. Okay, this particular plant, some people might recognize it because it's grown in as an ornamental in gardens, and sometimes people make lei out of they make a kind of kui style lei, where you just kind of string right through the flowers and nestle the flowers right up against each other. And this is also known as ohai ali'i. Okay, very pretty. It comes in different types. You can have all orange, you can have orange and yellow like this one is, you can have all yellow, different sort of variations on the same theme. We also have the Hong Kong orchid tree. Of course, it's not really an orchid since it's a bean family member, but it does somewhat look like an orchid in a way, yeah? But this is another plant that has a flower of the Caesalpinia type. So we just looked at 2 different kinds of trees. Whereas the mimosas we looked at, mimosa type flowers, we had what? An herb, right? A kind of ground crawling weed, as we might call it. We also had a couple of tree types, and the faba type we included an herb, okay? And I think another one as well, plus a vine. Now the Caesalpinia type, this one here, we looked at one tree. This is another flower of a tree type, Hong Kong orchid tree. And here's from the yellow shower tree. This is a cassia, okay, cassia type. And all those beautiful trees that throw out all those beautiful yellow flowers, the people who own the trees grumble because they have to sweep it up. They call them rubbish trees. It's still very beautiful. And this is one of the members that made what we call the rainbow shower tree. They cross a yellow flowered cassia with a pink flowered cassia. So what you have is flowers all in shades, all the way from yellowish all the way to pinkish, okay, mostly peachy color, and all variations in between. Another example of the Caesalpinia type of flower. So you can see all these different kinds of flowers all make for, the members in one particular family, the Fabaceae. Okay. Another feature of this plant is, of course, the fruit. Remember when we were talking about flowers and fruits? The fruit of these plants tend to be a legume, and you can see here these fruits of poinciana. Okay, so this one here, you can see that it opens along 2 splits. So this is what it usually looks like, including some of the plants that we looked at before. Okay, and also if we look onto the Elmo right now, okay, we can see here a fruit of Royal Poinciana, also known as Delonix regia. Okay, so if you look at it, I just went and got this a little while ago, you can actually see a split on one side, and then you have a split on the other side. I'm not going to open it up because I think these fruits are rather old, but still, legumes are fruits that split along 2 seams. Remember that definition? It's a dry fruit that splits along 2 seams. Okay, so the fruit of many of these legumes are, of course, legumes. That makes sense, yeah? So the fruit actually splits along 2 seams, and the fruit is actually dry when it's ready. So if you think, well, if it's a bean family or it's a pea family, when you go and buy green beans, why are they green? Well, probably it's because people harvest them before they're ripe, because when they're ripe, they're ready to disperse the seeds. So what they'll do is we people will actually harvest peas like snow peas, or harvest green beans or wax beans when they're still immature yet. Then they're still tender, and you can actually eat the whole fruit, including the seeds that are inside. Okay? So this legume generally has only one row of seeds. All right? Okay, furthermore, okay, the seeds of these plants, of some different kinds of legume family members, okay, are important food, of course. Here you see a whole bunch of green beans. Doesn't that look good? Yeah? So seeds are important foods to people. Okay, why would that be? Well, for one thing, okay, it provides much oil and protein because the seeds, remember, are made of three components. You have the seed coat, you have the embryo, which is a new baby plant of the next generation, and you have endosperm. When I showed you that peanut, that little peanut that I split in half, you had the two cotyledons, which are also food reserves. Therefore, when you have a lot of food reserves, that makes for carbohydrates usually, and also in other cases, such as brown rice and other whole grains. You also have things like, the bran, covering that, which makes for fiber. Anyway, so these legumes, their seeds provide both for carbohydrates, also other elements such as proteins, because beans are also like a go-to vegetable, go-to food in order to get really good quality protein, okay? And also in these seeds, you'll also have oil, so you have carbohydrates, you have fats, and you have proteins, the three macronutrients that you need for your food, right? And another thing about these legumes, many of these have higher protein content in their seeds than any other plants. Okay, they're higher in protein than other plants at all, including the grasses, which of course serve much of our carbohydrate need. And they do contribute some proteins as well, all right? Furthermore, okay, what is the reason for this? Why do legumes have so much proteins? Okay, for one thing, they have these structures near the roots called nodules. Okay, and these nodules, here's a photograph of a cross-section of this. These nodules contain bacteria. Okay, oftentimes these nitrogen-fixing bacteria are already, they will actually infest the plant and make these root nodules. Okay, so these root nodules, there's an illustration in your text. Okay, so if we kind of go to the Elmo right now, we can take a look. This illustration in here. Here are the roots of a legume, okay, with these root nodules in there. Yeah, you can see these little bumps. I would hazard a guess that these bumps actually result from being infected by these bacteria. What happens sometimes when we get an infection? Well, sometimes the area will swell and you'll get wound tissue, right? So my own thing, I'll check on it maybe later on, is that when the plant is invaded in the root by these nitrogen-fixing bacteria, well, the root forms like wound tissue, yeah? Another thing that you see in plants sometimes are what galls. When an insect or some other sort of pathogen goes into the plant, it produces this tissue. It's like a callus, So I think similarly too, I believe that these roots will actually form these nodules in reaction to being invaded. But this is actually the roots of a healthy plant, a healthy legume. Okay, because many legumes do depend on these root nodules, okay, to allow for what we call nitrogen fixation, all right? So you have the nitrogen-fixing bacteria that have infested or have infected the roots of these plants, all right? And why are they important? Remember, we're just talking about proteins, right? Remember when we were talking about the components of a protein, that these are called amino acids, and amino acids have a central carbon. They also have a carboxyl group. They have an amino group, and the amino group has a nitrogen in it. So you need to have nitrogen to make amino acids, and you need amino acids to make proteins. So a lot of the legumes have these nitrogen-fixing bacteria in them that have infected them and infested them, which allows for nitrogen fixation. Okay, and these bacteria are also groups in the Rhizobium genus. So there are different species in this particular genus that does that. Okay, so these are bacteria that infect the plant. So what do farmers do? They will oftentimes rotate other crops, especially crops that feed heavily, that actually take up a lot of nutrients from the soil, such as corn, such as wheat, okay? So what the farmers will do, they will oftentimes intercrop or they'll rotate crops. They'll plant alfalfa and then they'll have wheat, or they'll plant clover and then they'll have corn, or they'll do soybeans and then they'll do corn, something like that. Because these legumes with these bacteria help fix nitrogen into the soil. So, so they can actually do that, all right? So what can they do? If a farmer plants some soybeans or alfalfa, something like that, some kind of legume in them, sometimes what they'll do is they'll just, so corn and soybeans oftentimes crop together, or they'll alternate crops, okay? Corn being a heavy feeder, soybean being a nitrogen fixer. So what they'll do sometimes is they might grow the soybeans or the alfalfa, then they'll plow them under. They'll actually return them to the soil. This is something that people call green manure. You actually have a lot of nutrients, okay, in the green material from the legumes, all right? And this is important in terms of nitrogen fixation. Another thing that people do is they will actually plant trees that belong to the family Fabaceae in areas where the soils are depleted or where you have lots of erosion, because these legumes will help build up the soil. They'll actually add nitrogen to the soil. So why don't we take a look at that, okay? So here's a diagram showing the nitrogen cycle, you know, more simplified, but don't worry too much about details. The concepts actually are the most important part. So what's happening here is that most of the nitrogen, okay, in the world is the nitrogen that's in the atmosphere. A good percentage of the gases that we breathe is nitrogen gas, which is in the form of N2. Two nitrogens bonded with each other, okay, triple bonds, yeah? Remember, so go think back on chemistry. So think back why nitrogen will have a tendency to make 3 bonds with another nitrogen. So I'll have you figure that out, okay? This form of nitrogen is not available to living things. We breathe it in, we breathe it out. We can't actually use it or assimilate it for anything. We can't use it to make amino acids, to make proteins, okay? So what happens, all right? What happens is that legumes, okay, legumes and nitrogen-fixing plants have these nitrogen-fixing bacteria in root nodules, okay, of certain kind of plants. What that does, you have these bacteria in the root nodules, and what will they do? They'll actually fix nitrogen. They'll take atmospheric nitrogen, or N2, and they'll actually do ammonification. They'll change it into ammonium, okay, NH4. NH4 plus, and what that does, then you furthermore have nitrification. Using other bacteria, nitrifying bacteria will change them into nitrites, all right? Other nitrifying bacteria will then furthermore, okay, change them into nitrates, all right? These forms generally are available to plants for other plants to use, and they can actually take up these different forms of nitrogen, incorporate them into their bodies, and then the animals that eat these plants and us, okay, will be able to take in amino acids. Well, actually, our bodies can build amino acids from the proteins that we take in while eating peanuts, while eating soybeans, while eating navy beans, a whole different bunch of beans, as well as grasses. Especially if you eat them in combination, they're really good, okay? For one thing, remember when we talked about grasses, we said that grasses or cereal grains tend to be low in, do you remember? They tend to be low in, well, let's see, let me make sure I'm making this clear. They tend to be low in, I believe, lysine and also in tryptophan, right? They tend to be low in lysine and tryptophan, two different amino acids. But at the same time, the grasses tend to be high in or have adequate amounts of methionine, all right? Beans are just the inverse, okay? They have low amounts of methionine or not enough methionine, but they have pretty good amounts of lysine and tryptophan. So when you actually, you know, like in Mesoamerica where people eat corn and beans together, and even in North America where one of the traditional foods in the northeastern part of the country was something called succotash. What is succotash? It's actually squashes, right? Squash, and also corn and lima beans that they mix up into a meal that you can eat, or into a dish that you can eat. And I sort of know this because I sort of knew somebody who was from New England, and that's, you know, like a classic kind of American dish, right? Using 3 different plants that are from the Americas, corn and squash and beans. Very nutritious. That will give you all the necessary amino acids that you need to make the amino acids that you need to make, okay? Alrighty, so in the nitrogen cycle also, okay, what can happen is that as, you know, living things will actually eat like this little, looks like some kind of a herbivore. This will eat the plant, and then later on, you know, animals that eat plants are eaten by other animals. So what you have is you have the ability of animals to get their nitrogen sources to make proteins, including structural proteins, right? As well as food proteins, as well as enzymes and others, very important. Okay, then when organisms, whether plant or animal, or if you plow under a nitrogen-fixing plant, what happens is there are denitrifying bacteria which will actually return, these different kinds of forms of nitrogen back into the atmosphere. So this is like an abbreviated version of the nitrogen cycle. Okay, so a nitrogen cycle is one of the, let's see, about 4 major cycles of nutrients in the atmosphere or in the biosphere. Again, this is one of them. I think the other ones are, let's see, water cycling is another one, cycling of phosphorus, and also carbon cycle. Those are the more important of them. Okay? Alrighty, then beans, of course, beans and peas, different members of the legumes, okay, they're very important foods. Why is that? Okay, think about it. The seeds don't have very much water in them, right? So these are all different types, different takes on, I guess, Phaseolus vulgaris, right? These are all different varieties. Okay, we have kidney beans here, you look like navy beans, pinto beans, a whole bunch of different kinds of beans, right? So the seeds don't have that much water in them. Therefore, people can store them away for a very long time. They will actually remain viable. Even if you go to the supermarket, you buy yourself a bag, one of those bags, what is it, 5-pound bags or something, of beans. If you're thinking, oh, I think I'm going to make myself some bean soup or something, Portuguese bean soup. If you get some of those dried beans and you actually put, one on the side, you can actually stick them in water and they'll swell up and they'll germinate, because even when they're actually in the supermarket, a lot of them are still alive. So this is good food, very good food. And some people might think, well, if you want to be a vegetarian, you might not want to eat a whole lot of meat. You can do it for health reasons, or you can do it for ethical reasons, one of which, remember that energy pyramid that we looked at before? That from one level to the next trophic level, you actually lose a whole bunch of energy. Only 10% at each level gets passed on to the next. So that's one ethical way of doing it. If you read a book like Fast Food Nation, talking about how food is made and produced and served to Americans and to many people all around the world, that's another reason, ethical reason why you might want to eat more foods, more foods that are based on plants. Another reason for that is, of course, health as well. Okay, so Fast Food Nation, very important book, very well written. It does have an agenda, but still, well documented, well served, so to speak. Okay, so beans, very good source of good quality protein, and for various reasons, also for ethical reasons, you could be a vegetarian as well. Okay, anyway, so then, okay, another thing, so in this group, beans and peas, among the most commonly eaten plants. Okay, beans and peas. Okay, bean plants and pea plants. Okay, some of them, look at that, a whole array of different kinds of beans. Okay, kidney beans, lima beans, pinto beans, navy beans, and etc. We're going to take a look at some of these next. Okay. So doesn't that make you kind of hungry? Look at these kidney beans here. Look at that. They're glossy and they're dry. Very delicious, You can make yourself vegetarian chili, or if you like with meat, you can make chili con carne, because of course carne means meat. Yeah, like carnivore means meat eating. Yeah, chili con carne, or just chili, with beans. You could put corn in it. You can actually eat it with rice or brown rice. That'll give you all the necessary amino acids that you need. Here's some pinto beans. Very attractive. They're kind of named after horses, I guess. Pintos. You remember that disastrous car, that Molotov cocktail car from a long time ago? Anyway, so that's unfortunately named. But here you have pinto beans. They're actually called pinto beans because they have this kind of splotching on them, just like a horse that's a pinto. And here we have, looks like some lima beans. These look like fresh lima beans. Yeah, component of succotash. And here looks like we have navy beans in a particular form. It looks like it's an open-faced sandwich with beans, and it looks like cheese. Looks like tomatoes in there too. Okay, and here we have green beans, many different kinds of beans. Okay, let's see. We also have wax beans, which look like green beans, except I think they're yellow. Okay, and you also have butter beans. So these are among the major beans eaten in the United States. Okay, and these plants, they tend to grow in the warm season, and they tend to grow in cooler areas. So warm season annuals, they tend to have a life cycle similar to many of the cereals, where they just live for 1 year. Yeah, they germinate, they grow, they flower, and they fruit, and then they pass away, they die. Okay, Another interesting thing about these beans, which makes them very good crops, very good plants to grow, is that they will tolerate lots of different kind of soils, all the way from slightly acid, I guess, to neutral, into basic soils as well. So they can tolerate quite a bit of variation in terms of soils, depending, of course, what kind of beans you're growing. And here you can see this is actually a kind of like a grotesque looking image, but this is actually a personification of summer, okay, just to show that it's a warm season crop. Here you can actually see these peas that make up her teeth. Here you have corn, a whole bunch of different kind of summertime harvests, right, that you can actually, summertime foods. And this is just like showing a cross section of some soil. Yeah, and this one happens to have some turf on it. Yeah, you have the base rock, you have the weathering action that is making it into soil particles. Now soil itself can be classified into, did we talk about this? 3 different types. You have sand, which is the coarsest, you have loam, which usually is a combination, and you have clay, which is very, very fine particles. So you have soils actually classified according to the size of the particles that make them up. Okay, so soil scientists, you know, that's always a good field to get into too, soil science, which is one of the corollaries to agriculture. Okay? All right, we also have peas, okay, all different kind of peas, including green peas, okay, and split peas, and etc., black-eyed peas, lentils, etc. Okay, chickpeas are also known as garbanzos. We have some illustrations or some photographs of these, and here we have some frozen green peas. Yeah, doesn't that look good? Think of, and we can have split peas, like this yellow peas that are split pea soup, very good, very easy to make, you know. If you want to add meat to it, you just need like 1 strip of bacon maybe. You want to set your split peas to soaking for a little while, for a couple of hours, soak them, then change the water, because when you change the water, it kind of helps to degas some of these, because of course, that's one of the things that people don't like to eat beans about, is because beans sometimes make people feel gassy, yeah? It's due to the fact that some of the products that they produce when they're in your digestive system, you cannot absorb or digest. So they kind of may result in gas. So if you want to make a nice pot of beans, or you want to actually make some soup and stuff, you want to soak them first and then change the water in a couple of changes of water. Okay, soak them first, discard the water you're soaking them, put fresh water in, help to degas it. Okay. Split peas, good split pea soup. One of the students told me a recipe. You just have to get maybe 1 strip of bacon, fry it up or slice it really small. You know, put it in nice clean water. After you had soaked the split peas, you put the peas in there. Then you cook it pretty slowly. Yeah. Usually, whenever you're cooking a soup or any kind of stew and you want to cook with meat in it, you want to make sure that the heat doesn't get too high, because if you cook it too hot, the meat gets bitter. Okay, this is one of the reasons why when people are making chicken soup or making bouillabaisse or any kind of meat-based soup, what they'll do is they'll cook it for a long period of time at a pretty low heat. You want it to cook slowly to have all the flavors in there. At the same time, you don't want to make the meat bitter. It's probably some kind of chemical reaction that makes the meat bitter if you cook it at too high of a heat. So when you're cooking, you know, making a base or a broth or something like that, you don't want to have it at a rolling boil. You actually want to cook it and simmer it pretty low. You're making chicken long rice, you can do that too, you know. You can actually cook a whole chicken, you know, skin it, you know, take the skin off it, take all the fat off it that you can, you know, put it in a pot, just let it cook on the stove at a very low temperature overnight. Just have it simmer very low, and then you skim off the fat and all that kind of stuff, and the meat will be really, really soft, and it won't be bitter too, okay? All right, I hope to become a really good cook someday. And here we have some black-eyed peas, all right? Okay, and we also have lentils as well. Okay, and here are some dried garbanzo beans, also known as chickpeas. This is really good. Okay, so if you're kind of thinking about vegetarianism, you can actually make something called hummus, right? Hummus, H-U-M-M-U-S. It's sort of like a Middle Eastern spread or dip that you make from garbanzo beans. And you don't even have to get the dried garbanzo beans like this. You can actually get the canned ones. Just put it in a food processor. What do you add? You add let's see, maybe olive oil. Some people want, you know, say you need to use tahini, which is a sesame oil paste. I used to just use to buy sesame seeds. You add garlic, lemon juice, and just blend it all up, and then you can use it as a spread on bread. Okay, because bread, of course, is made from grains. This is a good way to get a good balanced diet, because here you have peas, and then which is a legume, and then you'll have grain. Good balanced thing, and you could be just vegetarian. You can make variations on this. You can put hummus, you could put tomatoes on it, or all kinds of stuff on there, and make a very nice kind of thing to eat. You can also use it as a dip. okay, for vegetables, if you're doing crudités or something like that, yeah. Anyway, so cooking is sort of like an interesting thing for me. I've been collecting recipes for a long time. They say that cooking is sort of close to chemistry, you know. And generally, you have general way that you put food together, and you can actually do that across all cuisines if you like. Okay. Now, peas usually tend to be crops that are of the cooler season. So here is another personification, and this is a personification of autumn. You might be able to see autumn here at the bottom. And this particular lady is wearing things like grapes. I guess it looks like peaches, all right? I guess this is a persimmon, all right? And cherries, maybe this is like late summer, early fall crops perhaps, yeah? All right, so we're gonna get into a few in particular, okay, a few different kinds of plants in particular. Okay, so one of them, of course, especially in the United States, is the peanut. Okay, the peanut is also known as goobers. They're also known as groundnuts. Okay, they're a kind of legume in the genus Arachis. Okay, Arachis hypogea. Okay, hypo means under, and gea, of course, refers to geo, which means earth. Yeah, so here's a nice image of the peanut plant. Okay, and you can see here is representing the soil, the line of the soil above ground, and then generally what they'll do is they'll actually bear their fruits underground. Okay, and their fruit usually has two seeds inside, yeah? Their typical peanut. So it will flower above the ground, but then after the flower is pollinated and after fertilization happens, it actually grows downward and it pushes itself into the soil, all right? Interesting, yeah? Of course. The thing too is that peanuts, okay, we might associate it with Africa and also some places in the South, North America, but it originated in South America, okay, probably in the cooler, not really cooler areas, but in sort of this area here, sort of Andean, okay? And from South America, it was taken by those European, so-called European voyagers, okay, to Europe, I guess to warmer areas of Europe, such as Spain and Portugal. I think it might have been the Portuguese who actually moved it, okay, from one area to another. Could be that it originated in Brazil, not really sure right now. But it went to Europe, and from Europe, okay, the European colonists took it to Africa. Okay, then African peoples took it to North America. Okay, and of course we actually associate it with different areas. So we have to Europe, we have it going to Africa, the African continent. Then from Africa, it then went to North America. So it took a circuitous route, you know, to get to North America. And in North America, okay, it's mostly grown in southern states because it needs to have, I guess, relatively warm, I guess, you know, subtropical to mild temperate areas. So let's see if I can get this right. You know, it's a kind of shameful thing, but they say that Americans are among the people in the world that are most ignorant of geography, you know. Anyway, so Georgia, here, okay, North Carolina, here, all right, Texas, of course, Texas we know for sure, Alabama, here, okay, Virginia up here, and Oklahoma. Those are the states in the United States that actually do most of the farming, that will raise most of the peanuts that people consume and are used for industrial uses as well. Okay. Okay, so there are more than 1 billion pounds of peanuts are consumed every year in the United States. Here's an image of a person after pulling it up, and here you see the groundnuts, yeah, the little fruits that had been underground. All right, so how did this happen? Okay, so here we're actually looking at the fruit, okay, of this plant. Okay, typically has 2 seeds in the fruits. Yeah. Okay, so for one thing, for another thing, you have a lot of them being consumed mostly as snacks. Here you have a candy with a core of a peanut with chocolate over that and a candy shell over that. Here you have one that's sort of peanut butter cups. Here you looks like you have some cheese crackers that has peanut butter kind of smeared in between them, and etc. And here, of course, we have regular processed, not really processed, but they're actually prepared peanuts for consumption, you know, as a snack. Right? And peanut butter, okay, peanut butter as well. Now, of course, you might remember from when we were talking a little bit earlier about nutrition, that peanut butter most of the peanut butter that we might buy is actually partially hydrogenated. That means it's been processed to add hydrogens onto it to make it solid like this. Because if you were to go to a health food store, like locally, go to Down to Earth or to The Source or places that sell organic peanut butter or unadulterated peanut butter, what you'll get generally is you'll get some peanut butter at the bottom. You have the oil floating on the top. So what the people who process the peanut butter do, other which are more I guess you might call more commercial types, is that it would be really solid, easy to, you don't have to stir it up before you spread it. You can actually just spread it on your bread or whatever you're going to eat it on crackers, or you could eat it with fruits or something like that. But generally, most of the peanut butter that's consumed in the United States is probably hydrogenated. It has partially hydrogenated peanut oils in it. Okay, that's usually what I prefer myself. I have tried to eat organic peanut butter, and it's good. It's tasty and everything like that, but it is, if you're storing it in the refrigerator, then you have to take it out and you have to stir it around, so it is an extra step. But probably, this is hypocritical, sort of, but probably non-hydrogenated peanut butter is probably better for you, but just for convenience, I tend to buy like a regular name brand, or even the house brand. If I buy it from a supermarket that has generic products, it's just easier, So peanut oil, furthermore, is another sort of product that we get from peanuts, all right? And these are used in the hydrogenation process that we talked about before to make margarine, okay, which is, of course, artificial butter, right? And they use it to make shortening, like vegetable shortening, such as Crisco, okay, which was the first one. Okay, and you also have other oils that are used, salad oils, cooking oils and stuff, because peanut oil is very good to cook with. It has a very high, what they call smoking point. That means you can heat it pretty hot and stir fry something very quickly at a high heat, thereby sealing in nutrients, and so you don't actually have a degradation of the nutrient quality inside of vegetables or some such like that. So peanut oil is used very much, I think, in Chinese cooking, yeah, because it has a high smoking point. You can actually heat it up pretty high before it actually starts to smoke or to lose its shape and things like that. So peanut oil, very good if you want to do a stir fry, classic, all right? Furthermore, not just that, is peanuts are also very, very useful, because when you actually express the oil out of the peanuts, and etc., this, what's left of it can be used to feed livestock. It's very nutritious, lots of protein in it, and oils, okay, and also carbohydrates as well. All right, so this is showing you that the peanut is a really, 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 really good thing to eat. And that I feel very sorry for people who have peanut allergies too, though, So here you see these livestock, so these guys would be real happy to eat the pressed cake that comes from expressing out the oil of peanuts, And another thing they say too, that hogs love peanuts, that given the opportunity, they'll go into people's fields and dig up these peanuts and eat them, which of course the farmer probably wouldn't like, yeah? Okay, now why did it get to be as it is now? There was a man named George Washington Carver, okay? He was a scientist, there's a story about him in your textbook. A very persevering sort of man, also a very humble man. Okay, so what he did is he actually investigated. He was a scientist. He investigated the potential of the peanut, okay, because what he looked into partly, is he actually was responsible for the renewal of agriculture in the southeast part of the United States because of the work that he did. Okay, he actually the land had been exhausted from intense cotton cultivation. Okay. So cotton is another heavy feeder. It actually takes up lots of nutrients from the soil. So the overworking of the soil, in the early part of the 19th century, the 20th century, was probably due to the fact that the soils were exhausted. You had, forest areas deforested, prairies all, their plants all gone, people planting crops. So that might have resulted in the drought that resulted in the Dust Bowl, okay, in the early part of the 20th century, okay? So what happened then is that, George Washington Carver, very interested in rejuvenating the soils in the South. He got to go to college and etc., okay, which is extremely extraordinary for a man of his time, okay? And so what he investigated was the uses of the peanut, and also he pioneered work on the uses of soybeans in temperate areas as well. Soybean is one of the biggest crops in the United States now, and this man was the person who actually promoted it and actually found uses for these plants, and sweet potato as well. These three crops, peanut, soybean, and sweet potato, they weren't on the map at all before George Washington Carver started doing his work on them. Okay, so it was due to George Washington Carver that, you know, agriculture was regenerated in the South. Okay, there were other plants that people could plant. Okay, so here you have peanut, soybean, and sweet potato. Okay, three crops, and this is just some of the crops that George Washington Carver actually put to the forefront of American agriculture. And of course, we know that soybean is extremely important as a crop in the United States. Okay, so here we have a soybean plant. Okay, and here we have some sweet potatoes, all right, from the ground. Okay, so soybeans, the next group we're going to talk about, so very important. Okay, peanuts, soybeans, and also sweet potatoes. Okay, we'll be talking about sweet potatoes next time. All right, so we also have the soybean. Okay, the name of this plant, of course, is Glycine max, a soybean. Okay, so here's a picture of the plant. All right, very important. Okay. Now, soybeans, people think that they were probably domesticated in China more than 3,000 years ago. They probably have some kind of archaeological evidence that kind of shows that this might be true. All right? Okay, so this is a little map of China. I think you folks have seen that before. Okay? And then from China, okay, from whence it came, it was eventually taken to Europe and then thence to North America. Okay, people weren't that interested though in the soybean because they had other things that they wanted to grow instead. Okay, but during World War II, all right, World War II, people needed certain kind of plant to replace other plants that people couldn't produce anymore, since many of the men went overseas to fight. So you had a lot of farms, you know, without people to be able to work them. So they actually turned to the soybean as a source of, I guess, machinery oil, cooking oil, and such, because they had war shortages on other sorts of food products and such. I think in World War II, didn't they have rationing of food? They had food coupons that people had to have because they were limited in the kind of sugar they could get, and flour and cigarettes and all that kind of stuff. Yeah, because during the 1940s, people didn't really know about you know, anti-smoking and things like that. In fact, in the GIs' ration, usually they included cigarettes as well. Okay, to the GIs. Anyway, what then developed is that the United States became and is right now the leading producer in the world of soybeans. Okay, and its products. Okay, partly due to the work of George Washington Carver. Right? Then another thing about soybeans is that generally you have to eat soybeans cooked. You can't eat them raw. Why is that? Well, it's because soybeans, you know, they have something called an inhibitor of trypsin inhibitor. Now, trypsin is something, it's a digestive enzyme, okay? And if you have this inhibitor, that soybeans, if you eat that, it will interfere with normal digestion of protein. So you need to cook soybeans before you consume it, all right? Okay, you can eat soybeans whole. You can have them dried. You can eat them like sort of like a snack food. You know, like peanuts are a snack food mostly, right? But you can eat them whole. You can eat them boiled. I think locally people like to eat that edamame, yeah, which is like cooked and frozen soybeans, so people like it as a snack. I remember being a young kid watching television at home, and my mom sometimes would cook soybeans for us, you know. I think it wasn't that popular at the time that she did that. You can also make soybeans into a paste, okay, into something called a curd, you know, which is when something curdles, it forms a curd, such as tofu. And you can also take in soybeans as soy milk, so-called soy milk. So here you see some tofu. It looks like it's at a Chinese restaurant or in a someplace. So tofu, okay, is very bland. It doesn't hardly have any taste in it. But what the good quality of it is that quality, because it will actually absorb gravies and such. Like if you actually do a stir fry and you have just a little bit of meat, you don't even have to have a little bit of meat. You can just have maybe a little soup base or something like that, or some kind of a food enhancer. You could actually squirt a little bit of what is that called? Liquid aminos. There's this thing called liquid aminos that you can buy from the health food store. That is actually made from soy also. Has nitrogen in it, proteins in it. So if you go to Down to Earth and you buy some hot food there or something like that, you have the option of squirting some of these liquid aminos, okay, onto your dish. Because I believe Down to Earth doesn't really sell any food that is meat-based. I think sometimes they sell dairy a little bit, that has dairy in it, but generally if you're allergic to dairy, one way you can do it is by eating products of the soy plant. Okay, here you have tofu, and here you have some soy milk. This is something that you can probably get like at Ballet, other places where they sell this Asian drink, which is a drink made of soy. Okay, how do they make it? What do? They'll actually take the soybeans, they'll add water to it, allow it to sit for a while, then they'll actually mush it up, they'll actually press it and squish it, and then the milk that floats to the top, you have it kind of curdling in some ways too, but the milk will actually be sold as soy milk. I think they have other sorts like that. They have Soy Dream that you can get over at the health food store. It's very good. Unfortunately, if you like sweets, it's very easy to drink 3 or 4 of those big containers like in one day. You know, sort of like you think, oh, this is healthy. You know, so if you're drinking soda, you might limit yourself to maybe 1 Coke or 1 Pepsi a day. You know, but sometimes if you're thinking that you're taking in something very healthy for you, sometimes what you'll do is you'll just overdo it. You know, just because you're thinking every time you drink it, you think, oh, this is healthy, so it's okay. You know, and of course it's not. Okay. Okay. Then you also have soy sauce, also known as soyu. Some people call it soyu. And of course, SOY is the SOY in soy. Yeah, people call it shoyu too. And here's some tamari, which is sort of similar. It's not as fermented or it's not kept as long as shoyu is. But still, what do? I think people, how do you make shoyu? You'll actually have it fermenting. Okay, the soy, you'll ferment it, and you'll also add things. Sometimes people put rice with it, sometimes put wheat with it, but generally shoyu is like a sauce. It is a sauce made with soy and others, usually a grain that is fermented along with it. And of course, this is like a staple of many Asian cuisines, yeah? It's very salty, okay, very salty. Sometimes they'll add salt to it too. Yeah, so it's very salty. So oftentimes I think in Asia, people don't really use salt so much, you know, the granulated salt or salt crystals, yeah? They'll usually put in soy sauce or other fish sauces and all that other good stuff, you know? Another way you can actually take in soy, okay, is through, you can actually take it in as miso. Miso generally, how do you make miso? You have fermenting soy. You also have rice, I think people put in there to ferment too. Then they grind it up and make it into a paste. And people can use it as a paste, like a spread on things. Of course, a lot of people might have the experience of taking in miso when you eat or you have miso soup if you go to a Japanese restaurant. What else? You can also make fish, misoyaki fish. You put miso, you can put some mirin, which is a kind of vinegar, rice vinegar, sweet rice vinegar. Or you could put sugar, you know, and a little bit of vinegar and mirin. And then what you could do is you can broil it. You could probably steam it if you want to, but you can make miso fish. This is especially good with fish that are very strong tasting, like salmon or what is it called? Asaba, mackerel like that, or butterfish. Very fatty fishes, very good for that. They also have tempeh, okay? They have tempeh that people can use, okay, for soy, all right? So soy is very, very nutritious, you know. It can be, let's see, up to 50% protein. Isn't that amazing? And it's very high quality protein as well, okay? Anyway, tempeh is another way. I think I've tried tempeh once, but I never acquired a taste for it. But still, some people really like this, you know? All right? And furthermore, you can actually have oil expressed from the soybean as well. That can be used for cooking. It can be used as a salad oil as well. It can be hydrogenated to make margarine. It can also be hydrogenated to make shortening. Remember, hydrogenation allows margarine and shortening to be solid at room temperature. And hydrogenation is when you add hydrogens, okay, and remove the double bonds between adjacent carbons, making up the structure of a particular substance, okay? Another good thing about soy, okay, is that they are a source of something called phytoestrogens. Phyto means plant, and estrogen, of course, is a so-called female hormone. Men have estrogens too, but not as much as women do. This is probably a structure of estradiol, okay, diol, which is one of the forms of estrogen, all right? And these are also known as bioflavonoids, bioflavones, right? Phytoestrogens. So this can actually be like an estrogen precursor, okay? Some people think that the very low rates, some low rates of some Japanese people in Japan, of very low rates of certain cancers might be due to the fact that they take in a lot of soy. They eat a lot of food with shoyu in it. They eat soy products, tofu, you know, and etc. Okay, so these phytoestrogens may be leading to low density lipoprotein levels. And of course, this is what they call the so-called bad cholesterol, right? So that can maybe lower levels of the so-called bad cholesterol. maybe also these phytoestrogens might be able to reduce symptoms of menopause and perimenopause, such as, what is it? Let's see, hot flushes, insomnia, irritability, So you might not think, I think we talked about this before, you might not think that menopausal symptoms has to do with you because you might be very young, but think about your mother, think about your auntie, think about your grandma, Every woman has to kind of go through this, and generally, odds are you're going to have to live, you're going to be living with somebody who is going through this. So this is something that might be able to alleviate some of the changes that people go through when they go through menopause and perimenopause. Okay, so I talk to the students that way. I'll say, you might not think, they might think, oh, why is she talking about menopause? Well, think about your mom. Has your mom been grouchy, more grouchy than usual recently? Is she more moody than she used to be? Well, it could be she's having perimenopause, which usually sometimes happens when women are into their middle 30s and into their 40s. Sometimes people are in perimenopause for 10 years. That's a long time to be grouchy, Anyway, I'm just sort of joking, but generally these phytoestrogens might be used, to actually alleviate some of the symptoms of this particular life phenomenon. It's not an illness; it's just a life phenomenon. Okay. Another thing too, here we have an illustration of part of the female reproductive organs, all right? And so another thing about soy is perhaps maybe reducing rates of breast cancer, okay, and other cancers that women are susceptible to sometimes, and maybe prostate cancer. And in here, we have an illustration here. So breast cancers, and some of the symptoms of breast cancer. So what they'll say, that women should do self-examination of their breasts every month. Okay, this might seem embarrassing, it might seem like a chore, it's boring, or it's painful, or it's embarrassing, or what. But one thing is that people don't want to have breast cancer. Most women, if they do have breast cancer, they find it themselves. Okay, they usually find it themselves when they're doing self-examination. So that you could have a lump, or you could have dimpling, uneven texture of the skin. You can have, so here, change in the skin texture or skin color. Okay, you can have a change in how the nipple looks, like the nipple could be inverted. Okay, that is another symptom. So if you have if you have a bloody fluid coming out of the nipple or clear fluid coming out of the nipple, all of these, you go to your doctor right away. I know people sometimes when they're worried about something, they'll think about it for a while and worry about it before they do anything about it. And then this is something that does happen. Doctors might tell the patient, well, if you found the lump, 2 or 3 months ago, why did it take you 2 or 3 months to come and see me? And the person might say, sometimes they'll say, it's because I didn't want to find out that it was bad news, Anyway, so just kind of think. So when you think about treating disease, or if you have a possibility that you might be sick, don't worry if people are going to think that you're a hypochondriac or whatever. It's more important to make sure you don't, okay? Because especially with cancers, if you catch it early, the prognosis for recovery is excellent. Okay, even some of the hard to treat cancers. And this is just showing parts of the male reproductive system. Okay, so here we have the prostate. Okay, let's see, where is it? Here it is. Yeah. Okay, so prostate cancer also, if there's something funny, if there's something wrong, you should go take care of it right away. I actually had a colleague I worked with, and he had a friend, a male friend, who died of testicular cancer. Okay, when he was a teenager. So there's some things that if you catch it early enough, it will be okay. So try, So I'm just trying to encourage you. Pay attention to your body and what it's telling you. Okay. Okay, so soybeans, the consumption of soybeans in whatever kind of form, whether it's shoyu, whether it's miso, whether it's tofu, that maybe this all can have to do with lowering people's rate of breast cancer and also prostate cancers. Because I guess one way that they were able to actually show this is they've done studies with people in Hawaii, okay, Japanese Americans in Hawaii, and also Japanese people in Japan. Okay, so they've actually done following people, for 30, 40, 50 years in terms of their health, and they do find that people that are in Japan have much lower of a risk, okay, of certain kinds of cancers. Might be due to their diet, because they don't eat as much, they never used to anyway, eat as much red meat, not as much beef, not as much pork, etc. Not even that much chicken, maybe. Sometimes they maybe eat fish, but they tend to eat them in small amounts. Another way that that people eat there is that they eat soy. That probably they eat soy almost at every meal. Okay, Okay, so that might have something to do with it too. Okay, so I think that in Hawaii we probably have a higher rate of people in a Japanese ethnic group, people that have prostate and breast cancer as opposed to people in Japan, because they don't eat as much soy or as much. So sometimes when you go to the grocery stores nowadays too, you'll see all these little old ladies and stuff like that all crowded around the tofu area and around broccoli stuff, because people, as they get older, maybe if they're retired, they're taking more care about what they eat and taking good care of their bodies. Yeah. Another thing about soybeans, very interesting. So remember that I said that soy can have up to 50% protein? Well, soy is actually higher in protein than lean beef. Isn't that a shocker? Okay. So soy, very, very good source of protein. So try to put that into your diet if you can. And for many people, maybe it's already part of your diet. Another thing that they say, though, which is kind of an interesting thing, is that also that Japan nationals, they'll actually have a higher rate of, I think, esophageal cancers and also stomach cancers. That might be linked to their very, very salty diet. Okay, not sure, I can't say that for sure, but some people think that there might be a connection between those. Okay, lots of salt. Salt is a chemical. Chemicals can cause, this is like a flawed reasoning, but they do find that high amounts of chemicals that's in contact with your body can maybe be mutagens, and mutagens can actually cause mutations that might lead to cancer. But remember, you need to have 3 or 4 mutations in a general body cell. The cell has to change 3 or 4 times before it becomes cancer cells. Okay, so don't worry about it so much, but at the same time, just be alert, pay attention to your body. Okay. Alrighty, so here's a piece of beef, okay, showing that generally soy is actually does have more protein than even this piece of beef. Okay, looks like roast beef. Now we have other legumes, okay, that we're going to talk about. Okay, for one thing, remember the lucina, the koa haole that we saw a little bit earlier? Well, some people call it a super tree of the forest. Okay, so this is actually a photograph of koa haole as we know it here in Hawaii. That people also call it lucina. Okay, the lucina is a genus name, and a particular species is Lucina leucocephala. Okay, why is it a forestry super tree? Well, okay, well, for one thing, it can grow up to 30 feet tall in 1 year. It grows very quickly. Okay, Lucina leucocephala. It's also a nitrogen fixer. Okay, another legume that fixes nitrogen. Okay, it's also, so because it grows so fast, it could be an excellent source of firewood for one thing. It could be also an excellent source of wood for construction, including for wood floors, including sculptures like this, including furniture, including something like this. This is actually an oddity. It's actually a palace or a building that's somewhere in the former Soviet Union. I don't remember whether it was in the Ukraine or in Russia. But this is a building completely built of wood. No nails or no metal nails, no metal joinery. It's completely built of wood. I just thought it was beautiful, and I just thought it was an interesting thing. Okay, so the wood from Lucina leucocephala can be used for construction, also for furniture as well. Okay, it can also be used for paper. Paper, of course, is one of the great things that we in our first world countries consume too much. I've known of people who subscribe to the morning paper. They don't even read it. All they do is they take the whole thing and they put it in the recycling pile. Okay, that's a lot of paper. Another thing about paper mills and paper making, look at all this pollution that's being generated by a paper company, paper factory, you know? So if we can cut down our production of paper, that would be good. I mean not production, but production and also consumption of paper. Okay? Okay, another thing too is since these Lucina leucocephala have nitrogen-fixing bacteria, okay, as well, okay, you can actually have 6 bags of leaves using it as a green manure. 6 bags of leaves will equal 1 bag of ammonium sulfate. This is like a chemical source of nitrogen, okay, ammonium sulfate. So if you actually just have 6 bags of leaves, okay, this is something that we also have seen illustrated in the lo'ikalo. Okay, in a lo'ikalo, usually you'll have these small little plants floating around in the water. This is an azala. Okay, this is actually a floating small little fern that grows floating on the water. It usually propagates vegetatively. So in the cells of these plants, you have these nitrogen-fixing bacteria. So people who are in a lo'i, people also have them growing in the rice paddies in Asia. Okay, so what do people usually do? When they're ready to have a new crop, they'll actually just plow under all these plants floating on. They're really small. They're only about this big, really, really tiny. They're called azala. Okay, they have these nitrogen-fixing bacteria in their leaves. And so they're used in lo'i kalo, or places where people grow taro. They also use in rice paddies, okay, to do nitrogen fixation. They actually will fix nitrogen for these particular plants in these aquatic environments, you know? Another thing that Lucina has been used for, it's used as a nurse tree. It actually provides shade, okay, and windbreaks for certain important crops, including coffee, including pepper, black pepper. This is black peppercorns, these are white peppercorns. The only difference between them is that the white peppercorns have had the black part taken off of them. That's why white pepper is actually more expensive than black pepper, is because it's more processed. Usually the more you have to handle something, the more expensive it is. Here we have fruits of cacao, also known as a chocolate tree. Okay, so the Lucina leucocephala has been used as like a nursery to kind of nurture and shade and protect coffee plants, black pepper plants, cacao, as well as vanilla. Okay, vanilla, which we'll see next. Okay, so here's a picture of vanilla flower, which is an orchid. This is the only spice, I believe, that comes from an orchid. So this area here below the flower, so this is a flower that has an inferior ovary. The ovary is here that has seeds inside, or the ovules. Okay, so when the flower gets pollinated and fertilized, this part all drops off. This part elongates and gets ripe. It's green, and then when people harvest it, they ferment it and then they dry it, and that becomes a so-called vanilla bean. Okay, it actually comes from an orchid. Okay. Another important use of legumes as for forage plants, and remember what forage is? It's something that that animals do. We can actually have animals kind of wandering around in an area in a pasture or such, and why are they good? It's because they're very high protein. So here it looks like you have a bull. Definitely this is a bull, not a cow, and used for animal fodder. So here you have him browsing around, nose deep in the grass. Okay. And so in a lot of these pastures, you'll have grasses and legumes growing together, and sometimes they do that on purpose. For that fact, you have alfalfa, okay, for one. This is a good forage grass for livestock, okay. And sometimes they'll use alfalfa to make, I guess they make them pellets, okay, for pets such as guinea pigs and rabbits and tame rats, tame mice, and lab animals as well. So generally they make like a proprietary mixture of alfalfa and nutrients to make a whole food for these animals. Isn't that neat? Yeah. You also have a whole bunch of different kind of forage legumes, such as clovers, okay, sweet clovers, and they're going to pop up in a minute. Okay, so we have clovers. Okay, see if I can remember these. Clovers like this. Okay, then you have sweet clovers. You can tell meli, M-E-L-I, means sweet. It means honey. Yeah, so this is a sweet clover. Okay, this is a vetch, and it has a typical faba type of flower, as you can see. And this is a Lespedistras, all right. And then, let's see. And then lastly, you have the bird's foot trefoil, all right. Now, the next thing we're going to talk about is for the future, beans for the future, perhaps. Okay. For one thing, we have something called a wing bean. Okay. Sophocarpus tetragonalobus. All right. And this one here is native to South Asia. Here's a photograph of the plant, you know, with this kind of pea-like flower on it. All right. And this is actually the bean, the fruit. Okay, this is very, very good stuff, very good stuff. I saw it growing, they had it growing over at the Pro City Urban Garden, which is near to LCC. And it can be a really interesting crop for the future, because all parts of this plant you can eat, okay? You can eat the fruit, whether it's cooked or raw. You can either break it up, put it in a salad, and eat that, okay? Or you can stir fry it, use it in a stir fry. Okay, I think people famous for being good vegetarian cooks are the Seventh-day Adventists, because I think that they're vegetarian, yeah? I remember I saw a video of a couple of ladies who are Seventh-day Adventists, and they're showing the use of this particular plant for making a stir fry, okay? And furthermore, the tendrils, because it is a bean, it does actually grow up on a trellis sort of thing, so it has tendrils. The tendrils are supposed to taste like asparagus. Isn't that amazing? Furthermore, the flowers are supposed to taste like mushrooms. You can make a whole dish out of just the parts of this plant. You can eat the leaves as if you would eat spinach. You guys, I guess you could cook them or you could make it in a salad. Okay, you can eat the root like a potato. Okay, isn't that amazing? Isn't that amazing, all from this one plant? Okay, so the thing about it too, maybe, you know, your textbook puts forward the idea that maybe the wing bean will be as important for tropical agriculture and the regeneration of tropical soils, such as like the soybean has been, you know, important for the regeneration of some temperate area soils as well. Okay, maybe that. Another possibility, okay, for the future is something called a groundnut. This is actually a Native American plant, okay, nitrogen-fixing legume, okay, in the eastern part of North America. So it used to be one of the main foods of Eastern peoples, the Eastern Native Americans, okay. So it's native to North America. You can eat the seeds and you can eat the tubers, okay, the underground tubers, all right. So very, very interesting because it's very nutritious, okay? The plant itself is up to 13% protein. Then we get to the jicama, okay? I think call it jicama, right? Pachyrizis erosus and Pachyrizis erosus, okay? Called the jicama. And this is native to Central America. It's supposed to have a little bit of a sweet taste, I think, so people eat it there. And they also eat it in Asia as well. You can eat the roots either raw, like in a salad, or you can cook it, you can boil it, or you can braise it, and etc. Okay? Anyway, so the summary for today. So those were possible legumes of the future, okay? So we talked about characteristics of legumes, okay, as well as we talked a little bit about nitrogen fixation, okay? We talked about an important food source, you know, as legumes, because they give us proteins, all right? Very important. And beans for the future, perhaps, okay? Alrighty, so today we talked about a complementary food that could be complementary to some of the grasses and the cereals that we talked about last time, okay, in various ways. We talked about the importance about legumes for the nitrogen fixation and all that, but that's all the time that we have for today. So I wish you aloha and we'll see you next time. Bye-bye.